Welcome back. We're in Giancoli Ch2 Question number 5. In a drag race, is it possible for the car with the greatest speed crossing the finish line to lose the race? Explain. Well, if you do follow any drag racing, you'll notice that quarter-mile times, or eighth-mile time for that matter, or any others, that oftentimes the car with the fastest speed isn't necessarily the winning car. Let's think about that. If I was just watching it from the side, I could see that one car might get faster than the other car. But maybe it only gets faster than the other car at the beginning. And maybe the other car gets faster than the first car at the end. So wait, we're saying how much we're changing our speed with. Okay, let's look at that in a little bit more mathematical sense. What if we looked at a position time graph here? And we're going to look at that for two different cars. Let's say car A in black and car B in blue. Now let's make it even simpler. Let's say that one of the cars was maybe cheating, or maybe they had a special agreement, so he's not cheating. But one car was just going to go, sorry about that. One car was just going to go a constant speed the whole time, and it was going to get a running start as well. So car A gets a running start and goes at a constant velocity the whole time. So we know that the constant velocity is going to have a slope that is constant the whole time. Great. And let's not even put numbers into it yet, because I bet you can figure it out without even numbers. And let's say that the end of the race, quarter mile, drag racing is usually a quarter mile or eighth mile, there's some ending position here. So let's say that this is the end position. That's the end of the race. They cross the finish line. Okay, great. Well, car B, let's say that car B starts at the zero, like that does, but it starts at rest. Well, if it starts at rest, the slope of that thing is going to be horizontal at the beginning. But then it's going to speed up. Now, if you're going to speed up, if you're going to get faster, then what's going to happen to your slope? Oh, that's right. Yeah, the slope isn't going to be constant anymore. The slope would get bigger and bigger and bigger, steeper and steeper and steeper, more and more positive, because the speed would get more positive, or really the velocity would get more positive. So maybe B would start off real slow, but then it'd be speeding up and speeding up and speeding up and speeding up. Oh gosh. And I drew that a little bit different than I wanted to. Okay. And actually, I'm going to draw this a little bit different. I'm going to say, what if it took a while for B to speed up? Yeah, that's what I want to draw. Boom. And now when I look at this, I go, okay, great. B took a while to speed up. It was, as any car does, it takes a while for it to speed up. A was already going the whole time. If we look at this, who won the race in less time? I think it's fairly clear to see that, oh yeah, maybe yellow is a bad choice. Oh yeah, A crossed that thing first in less time here, and B took a little bit more time. B definitely took a little bit more time there. Okay, cool. So if you're watching it from the stopwatch on the side, A definitely won the race. Although, who's going faster right when they cross the finish line? Well, A had this slope here, and the slope represents velocity. B, look at B's slope. What's B's slope? Well, if you remember, maybe you remember this from math class. And if you don't, that's okay. We're learning it right now. You can find the speed, or the velocity, at any point along here just by looking at, let's say we tried to do it for this point, just by looking at the tangent line at that point. So if I draw if I draw a linear line, that's a redundant statement, if I draw a straight line, then I could see that the slope is, whatever that is, if I could put numbers to it. Okay, cool, it's that steep. And I look at that and I go, well, in that case, it just happens to be approximately the same. But then down here, if I did the same thing down here, we could see, oh, that slope is less than the corresponding slope up here. Yeah, B is going slower at that point than A is there. It looks about the same here. And then, well, what about at the end here? That's what we actually care about. At the end here, if I draw that, tangent line there, it looks something like this. Now, that's a little bit crude of a line, but that's okay. If you look at that and you go, look at the angle of that thing. It's way steeper than A, meaning that B's velocity is way bigger than A, and we can tell that just from the graph there. So check this out. This graph shows that a car finished the race first. A finished the race first and won that race, but B was going faster at the end. So is it possible for the fastest car to lose? And the answer is yes. If they're speeding up like this, it also depends on how quickly they're speeding up. If you took another car and made it speed up faster, maybe it's like B, but it can speed up even faster. It's got a bigger motor in it. It might look something like this. Well, hey, now in that case, it's both got a faster speed at the end and it took less time. Okay, cool. That's it for that one. Have a wonderful day.